Hey, it's me again. Here we are back at Algebra 2. Today's Unit 6.1, or Lesson 6.1. Can't believe we're already in Unit 6. Um, is quadratic functions. Now, in quadratic functions, we have seen this extensively in Algebra 1. But of course, that was a while ago. You went through geometry, so Algebra 1 was a little while ago. So we have to kind of reactivate some of that knowledge that we learned back in Algebra 1 2 years ago. So I thought it would be a good idea to spend a little bit of time talking about quadratic functions and their characteristics. All right, so any function of the form y equals ax squared plus bx plus c, where the leading coefficient a is not 0. And the reason that we say that, we always get flipped out by all that stuff they put at the back, because if a was 0, this term would go away. And then we'd have f of x equals bx plus c, which is a linear function. Okay, so that has to be there in order to have a quadratic function, obviously. So here is my linear term, here's my quadratic term, and here's my constant. So exercise 1, evaluate the following using function notation. So the only thing you really need to be careful here is when you have negatives. Because so many times in our brains, even the best of our brains, like my brain sometimes will make mistakes like this too, especially when you're doing a lot of them and you're doing them quickly. And sometimes people think, oh, this is easy. I know how to do this. And that's when mistakes happen. So negative 3 squared, I'm going to remind you, is negative 3 squared, which is the same thing as negative 3 times negative 3, which we know is a positive 9. All right, so negative 3 squared is not negative 9. Now, just reminding you that negative 3 squared written this way is a negative 9. But that's not what this function is. This function is x squared. So the second one, this one's going to be 5 squared. So when you have positives, sometimes it's not quite as difficult. We just square it to 25. So B, talking about g of x. So we're going to evaluate g of 2. So that means we're going to substitute in where there's an x, minus 5. 2 times 4 minus 5 is 8 minus 5, and 8 minus 5 is equal to 3. And 2 times negative 1 squared minus 5 is 2 times positive 1 minus 5, which is negative 3. Easy enough, I hope? Let's slide this up a little bit. So taking a look at h of negative 2, be careful of that extra negative that's right here. So negative 2 squared plus 4 times negative 2. Turns out now you can put this whole thing in your calculator. Don't feel like you have to do this in your head. So if you're the kind of person that gets confused once in a while with all those negative signs, use your calculator. Just make sure you're using negative signs and not subtraction signs. So this becomes negative 2 squared is positive 4, and then positive 4 times negative 2 is a minus 8. So this is negative 12. And the last one is negative 3 squared plus 4 times 3, which is negative 9 plus 12, which is equal to positive 3. Hopefully you're feeling pretty good about that. So in exercise 2, consider the simplest of the quadratic functions y equals x squared. Now that y equals x squared that I have a box around already is called a parent function. Some of you might know it as the mother function, but generally in mathematics we call it the parent function. All other quadratics kind of are compared to that parent function, which is y equals x squared. So this we don't need our calculator for because we can kind of do this squaring pretty easily in our head. Because negative 9 squared, when we're considering making a table, negative 3 squared is positive 9, negative 2 squared is positive 4, negative 1 squared is 1, 0, and then 1, 4, 9. This is the beautiful thing about tables and quadratics is that you have this symmetry. All right, like right here, we haven't talked about the vertex yet, but here is going to be your vertex or your turning point, and all the other y's become symmetric around that. And I'll show you what that looks like again when we get to exercise 2. So sketch the function. So that's easy enough to do. So negative 3, 9. So negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2, 4. Negative 1, 1. 0, 0. And if you get half of it, the rest of it just follows suit that it's going to be symmetric about that turning point. So this is the beautiful parabola that we have, y equals x squared. Please get in the habit of labeling your graphs, even though the region says if you only have, if you have more than one equation on a set of axes, then you have to label. In this case, we only have one, but if we're always in the habit of labeling, we'll never ever lose that one point that we'll lose for not labeling. So say the vertex. Well, we talked a little bit about the vertex. Another name for the vertex, and you might want to write this, vertex is the turning point. It's where our graph changes from increasing to decreasing or decreasing to increasing, like in this case. All right, so we talked about what the vertex is. The place where our graph changes direction is 0, 0. So we can see that on our graph, and we can see that on our table pretty easily, because this is what I talked about right here. It's that number in the middle that doesn't have a partner. The 1s, the 4s, the 9s, they all have partners. But that 0, 0 is there all by itself because it's such a special point. It's the turning point. Now state the equation of the axis of symmetry. Now, another word for the axis of symmetry is the fold line. So if I took this and I was able to fold it along this line right here, it would fold on top of each other. Now, because of the type of parabolas we're doing this year, we're only going to be doing ones that are heading either oriented upward like this or up or downward like this. Our axis of symmetry is always going to be of the form x equals, because it's always going to be a vertical line. So in this case, x equals 0 is my axis of symmetry. And there is a direct relationship between what my x is here and what my x in my vertex is. They will always be the same number, which is helpful. Okay, so E says over what interval is this function increasing? So increasing, interval means x values, right? Because we always like to spend a little bit of time, x values. So if it's increasing, that means it's heading in an upward direction. As our x's get larger, our y's get larger. That's the definition of increasing. So in this case, you can see from that vertex, which again was right here, from the vertex to the right, our graph is increasing. So there's a couple of ways we can do this. We can say x is greater than 0. We can't say greater than or equal to, because at that vertex, it's not increasing nor is it decreasing. It's kind of like just that turning point where it's changing its mind. All right, so you can write it in what this is called set builder notation, or you can say 0 is less than or equal to, oh, no less than or equal to, sorry about that. 0 is less than x, which is less than positive infinity. That's another way of writing that. Or you can use interval notation, where our lower bound is 0 and our upper bound is infinity. So whichever way you like to write it, you do not have to write all three ways here. So as whichever way you are most comfortable with writing this, that's the way you're going to write it. So when you're done with this, let's meet at exercise 2. This one will be a little bit more challenging, but you'll see how we're going to go through the same steps we went through with this one, except we're going to use our calculator this time to make things a little bit easier. All right, so consider the quadratic function f of x equals negative x squared plus 6x plus 5. So again, I am of the school that I like to put a box around anything mathematical. So this says now determine the vertex or the turning point of this function. Well, before I do that, because C says graph the function. So my advice is go to that calculator and come up, and by the way, I do this on here. I always put my table somewhere on my graph so I don't have to go back and forth between that and my calculator. So let's pull up that calculator and see what it looks like. So when you put this in, notice this has a negative in the front. It has a leading coefficient that's negative. Negative x squared plus 6x plus 5. And I'm just going to bring to your attention, do not put a subtraction sign in there because I think it will give you an error if you put a subtraction sign in there. All right, so this is what it looks like. And they're asking us for the vertex. And that vertex is not visible in our window. Now, could you zoom out? The answer is, of course you can. So you remember how to zoom. You go to Menu, you go to 4, you go to zoom out, and then you just keep hitting that center, that middle of your mouse until it comes into play. So you can see it here. Now there's a beautiful function here using menu to show that now that we know this is a maximum point. If it's opening downward, you're going to have a maximum point. If it's opening upward, you're going to have a minimum point. So you can go to menu, to analyze, to maximum, and you get this lovely little stash line, and you can slide this over and your maximum will come into view. So 3 comma 14 is my maximum. That's one way to do it. The other way to do this is go to your table. So go to Control T. And this one, it just happens that the vertex is in sight on my table. Sometimes you have to scroll up and down looking for it, but this one actually is here because if you look at this 3 comma 14, you notice that it has that symmetry around it. And we're going to write down every point that fits on our graph. All right, so let me just get rid of this, clear ink, and we're going to rewrite this table on our paper. So let's see what we're going to get. The first thing I usually like to do is I like to put the vertex in the middle and circle it so I know where it is. So I know that 314 is my vertex. Then I'm going to go 2, 1, 0, and I keep going. This is 13, this is 10, 0, 5, negative 1, negative 2. And if I go to negative 2, I get negative 2, negative 11. And that's not going to fit on my graph. So you know what? I don't need to include that one. So let's do 4, 5, 6, 7. And 4 is, now if we did this right, this should be 13, this should be 10, this should be 5, this should be negative 2, which it is if you check your table. All right, again, we're not going to go to 8 because 8 we get back to negative 11, which does not sit on our graph. So this one, the A says determine the vertex. Well, we determined that. That's 3 comma 14. So that question is all about looking at your calculator and figuring out where that turning point is. So let's graph this. So negative 1, negative 2, down here, 0, 5. Here, I'll do it for you. There we go. So a little bit of math magic there. So that's what it looks like. And if you notice that turning point, again, our turning point is up here, and our axis of symmetry sits right here. And if you notice, and if you did it properly, you should have a point here, 2 away here, 2 away here, 3 away here, 3 away here, 4 away here, 4 away here. So you should see, so please pay attention. Make sure that you're doing a nice job with your graphing. Always give it a label. Y equals negative x squared plus 6x plus 5. All right, and let's finish reading the rest of our questions. So D says, why does the parabola open downward opposed to y equals x squared, which opens upward? All right, so what was the only difference between this one? Well, there was a couple of differences, right? It was a longer. I'm going to remind you that the one we just did was y equals negative x squared plus 6x plus 5. So what I want you to recognize here is this leading coefficient. So the leading coefficient, which is the coefficient of the quadratic term is negative. That is why this one opens downward while the other one opens upward. Notice how this is polished too. I didn't bring this to your attention, but obviously you can't use a ruler for this, but notice how we have arrows. If they give you an interval, then you stop. But if they just tell you to graph it, when you keep going and your range is infinity down here, you make sure you've got arrows here. E says, between what two consecutive integers does the larger zero of this equation lie? Show this point on your graph. So the zero, there's two zeros here, right? There's one here, and there's one here. So the largest zero, the one they're actually interested in, is this one that's right here. And notice how it does not fit on a lattice point. It doesn't lie right there on one of those nice cross marks. So there's a couple of ways that you can do this. You can actually solve this equation, or once again, you can go back to your calculator and you can do this lovely thing. Let's take the control T, let's take the table off, and we're going to go to menu again. We're going to go to analyze, and we're going to do our zeros, number one. And again, you get that nice little dashed line. You have it on one side, you hit the middle, and then you slide it over. Slide it over. It's not sliding over. Here, now it is. Sometimes on this thing it doesn't work so easy. Let's try again. Menu, analyze, zero. Hit enter. Let's try using this one. Nope, it didn't do it. Enter. Now it does it. So you can see how once I hit there, it hits at 6.74 comma 0. So that is our larger zero, 6.74. So when it asks here between what two consecutive integers, we're going to say, make sure you use the complete sentences, the larger zero is between 6 and 7. Remember what the word consecutive means. It means two numbers that are right next to each other on the number line. 5 and 6, 0 and 1, -2 and -3. All right, those are all consecutive integers. All right, if you need to go back and rewind this because I went too fast, please feel free to do that. Come in with questions if you're not sure where something came from, or if you want and you want to learn how to do this better on your calculator, you make sure you ask me when we get back into class, and I can show you when we can practice this together. All right, moving on to exercise 4. Now, exercise 4, we're going to do this whole thing in our calculator, because it's not asking us to solve anything algebraically. So when it asks us to find things like the x-intercepts, the y-intercept, the turning point, things like that, we're going to use our calculator because it's just an easy way to do it. So let's pull up this function on our calculator right now. There you go. So x squared minus 11x minus 26. The first thing I do is I make sure that the function that I have on my paper matches the function I have on my calculator. Because if it doesn't, then there's nothing that's going to be right about this. Now, there is only really one piece of information I can get from this the way it is, and that's one of the zeros. It looks like one of the zeros is -2. So that gives me, if you look at your paper, that gives me my A. But I don't know what anything else is. I don't know what A is, D, C, or B. But again, there's a way that we can do this. We can either look at our table or we can look at the graph itself. So in this case, let's pull up the table, Control T. And I'm going to remind you, when we're looking for the x-intercepts or the zeros, y is equal to 0. So we know one of them is 2. No, we know one of them is -2. All right, so when we go up, there we go. So there's our -2. So there's one of our zeros, and we can see that right here on our graph. We can see that -2 right there. So delete that. So I know that's one of them. Now to find the other one, I know it's going to be a positive number, so I'm going to just keep going until I find 0. Okay, sorry about that. I had a little interruption. I think what we were doing was looking for the second 0. So if we slide down and we look for that second 0, there it is at 13. So our two zeros, if we go back to our point here, our x-intercepts, so A, I guess we'll do points here. So our point is going to be -2, 0, and B is going to be the point 13, 0. The y-intercept is basically when x is equal to 0. Remember, this is when y is equal to 0. So when x is equal to 0, you get 0 squared minus 0 equals and minus 26. So I know here it's going to be 0 comma negative 26. So many times this number right here, just like in our linear functions, is our y-intercept. And the turning point C, now let's go back to our graph again, and we're going to look for that that number that's in the middle, and let's see if we can find it. Let's head up and look for the symmetry. And if you look, this one's actually missing. There's no number between these two. See these two here? So sometimes the best thing to do here is to go to your, let's Control T. Let's take this off. Let's zoom out. So menu, zoom. We're going to zoom out, because I'm trying to get that, I need that, the turning point, right? So I know it's really small, but that's what I need. I need to get it on my window. So there's my turning point right there. And I'm going to do the same thing. Menu, analyze, and this time I'm going to look for my minimum point, which is number 2. All right, I'm going to slide this over. I'm going to hit enter, and then I'm going to keep sliding it over until it highlights, and then if you notice, the minimum then stops. So 5.5 and negative 56.3. All right, so 5.5 and negative 56.3 is my minimum point, my turning point. All right, over what interval is the function positive? So interval, so what x values is my function, so my y positive. So what we're looking for is where the y is positive. So the y is positive here and here. So what we're doing is we're looking between here. So it's not between here, it's on the outsides of this one. So what are those 2 points? We know that x has to be less than -2, or x has to be greater than 13. That's where our y function is positive. So we go from this point this way and from this point this way. All right, we can discuss that a little bit more if that's confusing to you. All right, so make sure you come in with that question answered, or ready to ask that question when you come in. All right, so 23 minutes, not half bad, 23 and a half minutes. So until next time, always make good choices, and we'll catch up again soon.